Michelson ने क्या किया? What is done by the Michelson? I have already explained in the what is the Michelson interferometer, and you have done the experiment. Okay, so as I have already explained, there is a two mirrors. Okay, parallel mirror have the same thickness. They have the same thickness. Okay, and light will pass through these mirrors. Okay. That will be divided into two parts. One will move this mirror, and one will be moved this mirror. Okay, and you have done the experiment in the experimental lab. Okay, this mirror is half polished. Okay, and this is a plain mirror. Okay, the length, this length and this length is the same. Okay, the length of the distance between this M1 mirror and M2 mirror is the same. Okay, and here is the laser gun. Okay, and here is the filters. Okay, different filters that will be sharp the light. Okay, okay, and light will be come from here. So this length will be the same. Okay. Firstly, a light will pass. One light will be passed from here and will be collide this, and then this will be reflect, and due to this will be come here. Okay. And here is observer. Okay. There is a telescope or observer. Okay. Yes. Okay. Here light is passing if this length is D and this length is D. Okay. Light will pass through one time, two times, and three times, and then reflect toward the observer. Okay. Okay. So this when the medium will be changed, the frequency and the light will pass. These two mirrors are these two lenses have the same length. Okay, plain lenses, and light. No, this is plain. Okay, and these are the parallel, and this is half polished, and these are mirrors. Okay, light will be partially from this mirror will be partially divided into two parts. One will be go upward if that is point is D. One light will be moved upward, and one light. This is a laser light, and that will be there is a many filters that will be sharp this light. Okay, and polarize this light. Okay, so this light will be passed through this and then reflect back, and then after colliding with this will be come toward the observer. Okay, okay. And okay, yes, mirror. They are two plane mirrors, M1, M2. Okay, reflector mirror. Okay, so this is observer. Okay, O observer. Yes, this is half polished. The light will be due to this polish. One light will be moved toward here. One light will be moved toward here. Okay, when light will be passed from here. Okay, this one half light will be passed from here. This will be passed three times from the mirror. How? The width of this mirror is the same. First time when passing through this mirror, 1. When passing through this mirror, 2. When it reflects back, then it is third time. Okay, so that will be light will be passed. These rays will be passed through the these mirrors of thickness D 3 times. So the medium, when we know that when light move from any medium, and if the medium change and density of the medium change, then the frequency will be changed. Okay, and the wavelength will be also changed. So the changing of the wavelength will be occurred due to the 3D medium. Okay, 3D thickness of D, 3D. Okay, so light is passing through this, if I can say that this is ray 1 is passing through 3 times from this mirror, these mirror. Okay. Similarly, when the second light, okay, 1, 2, and 3. The second light will be also pass through the 3 times. So the change in frequency or wavelength will be same for 2 lights. Okay, 2 laser lights. Okay, so they will join each other and make an interference pattern here. Okay, got it? And you will observe the rings. Okay. Okay. Now, if we see deeply this instrument, actually Michelson, the lab Michelson is interferometer is a very simple, but actual actual Michelson interferometer was a very complicated. It may be rotate, and it is put it on the mercury, and that may be a rotate in any angle, and that can be measured the angles of rotations. Okay, so but in simple way, this is a Michelson interferometer. Okay. This point is P, okay, if I say this is point of P, okay. Light is, ray 1 is, if I say this is ray 2, okay, this is ray 1. This is ray 1, okay. So, okay, this is observer. If we set it in this way, Michelson set it in this way, that the direction of this ray, if we set Michelson interferometer in such a way that direction of ray R1 will be aligned with direction of Earth. If we align in such a way, because it has ability to rotate, okay. If we align in such a way that direction of this ray 1 is along the motion of Earth. This is the velocity of light, okay. This ray 1 is VR1 is moving in this way, okay, and Earth is also moving in this way. Okay, both are aligned. Okay, they both have a same direction. The velocity of light, that is, what is this? That will be c. This is velocity of light. Okay, that is c. Okay, here ray, and this is observed by stationary thing. This is VA. Okay, this is velocity of Earth, and observer is standing. And Michelson interferometer is put it on the किस पे है? Earth पे है, ठीक है? So velocity of observer will be, yes, what will be the velocity of observer? This is the velocity of light with respect to constant observer at rest, ठीक है? That is VA, ठीक है? As we have done in the case of the speaker, okay? This is VA, okay? Okay. this is velocity A. Okay, VA is the velocity C. Velocity of Earth is, that is equal to, because observer is VB. Why? Observer is on Earth. That is moving along the Earth. If he is sitting on the Earth and Michelson interferometer is put it on the Earth, then both are moving with the same velocity, Earth velocity. Okay? Okay. So velocity of Earth is Vp. Got it? Okay. No, velocity of Earth is not Vb. Sorry, I was wrong. The velocity of Earth velocity will be velocity with respect to at rest. That will be Earth velocity will be Ba. Sorry, that will be Vba. Velocity of observer sitting on Earth. Because we have said that this is if this is A, yes, this is B, A is stationary, this will be defined as Vb, yes, yes. So velocity, this is velocity of Earth, and that is velocity of observer. ठीक है? Okay, got it? B. If arrow is toward B, then that will be BA. Okay, if you see the last one. No. Okay, that will be defined as a VP. Okay, from B to A, from B to position vector of B with respect to A. Okay, okay. So this is that must be a constant. Okay, because we are considering the initial frame. Okay, acha. This is the velocity of observer. Yani velocity of observer with respect to frame at rest. Okay, okay. Mean A. Okay. A is frame at rest. B is moving. So BA is the velocity because velocity of Earth with respect to frame at rest, and man is standing on the Earth. That's why that will be also the velocity of the man too. Okay. So the velocity of observer with respect to from frame at rest. Okay. So all this. Okay. That's okay. Now these are the aligned. Here ray 1, this is ray 1A, okay. Now this is VBA and this is R1A, okay, mean first time when moving, so, okay, ray 1, okay, at A. So that when if it is moving, both have the same direction, VA and V. Okay, if both have same direction, the velocity of then VP. What will be the VP? VP. What is the VP? Yes, velocity of light absorbed by V. Okay, both are moving. Earth is moving in this way, R1A. Earth is moving in this direction, VB is moving in this same direction. Both are moving in the same direction. Then VB is, we have the formula, VB will be equal to magnitude, what is the, I have told, that will be equal to, no, if both have the same direction, I have said that that will be equal to VA minus BA. Okay, that was the formula. Okay, the case 1, both is the same, moving away, both have the same direction. Then this VB equal to VA minus BA. VA is, what is the VA? VA is constant, and no, constant, not constant, that is VA, velocity of light with respect to observer A, that is C, and BA, velocity of Earth. Okay, so this will be by B, velocity of light observed by, velocity of observer with respect to frame at rest. Okay, so this will be C minus V. Okay, this is the case 1, and this RA will be this ray will be observed velocity. This velocity will be observed. Ray 1 will be observed. VD will be observed. The velocity for ray 1, that will be VA minus VB at C minus Earth. That will be a difference. Okay, got it? Okay. In this case, ray is coming back. This was a case A. Now case B. What is the case B? Case 2. We may say that this is A1 because this is about the ray 1. Okay, and this is case A2. Okay. Now after reflecting from mirror, the velocity of R1 B mean backward. No, okay, that will be move backward. Earth is moving. Earth तो इसी तरह ही मूव कर रही है. This is Earth, that is VBA. Yes, velocity of Earth with respect to rest. Okay, so now VB is equal to VA plus VBA. If the direction is opposite, then both will be added. And this will be equal to VAC. Okay. VB is V Earth. So that will be case. Yes, you are right. This is okay. VB. Okay. Got it? Acha. This was a case A. Now about what is the about case B. That is a very important case. That's why I have done the case D. Okay. What about the case B? Case B. Yes. B also has a one is moving upward, one is moving downward. When moving upward, okay, or moving upward. Now light is moving upward. This is VA. That is C. ठीक है, VA. This is C. speed of light, because this is a laser light, and this will be velocity c, okay, according to frame at rest, okay. Okay. Observer is showing that it is moving upward. Earth is moving. Observer is moving toward. According to Earth, the same. That is VBA. That is V Earth. Yes. This is B. Okay. This is perpendicular. The perpendicular. That was the case. Yes. 4. Last case. When velocity is perpendicular with respect to observer. That was the case. With respect to B. B is as a observer. Okay. When making angle 90 with the velocity, this is the velocity of Earth. And when sound is making angle 90, that was the case. When sound is making angle 90 with respect to observer. Now light is making angle 90 with respect to observer. Okay, so that is that whole case. Okay, and so this will be this velocity. This will be velocity observed by. This will be VB. Velocity observed by. And what will be this? I have already explained. What is this? What is the VB? VB will be VA square minus BA square. Yes, that was. Yes, that is written. Yes. Okay, so this will be equal to this. Yeah, this is written. Okay, the same formula. Yes. Okay. Okay. Got it? And case B2. What will be the case B2? Yes. Now the light is coming back. Even light is coming back. Okay. VA is C. The case is same. Now direction is different, but magnitude will remain the same. Okay. So that will be also a VB VA square minus BA square. Direction, no. Magnitude. We are finding only the magnitude. Okay. So okay. So this is case B's. Okay. Both, when we add both. Okay. This will be the case B. For upward, even for upward, this will be VA square minus BA square. That is upward. Okay. That means downward for downward, that will be also. No, sorry, we have to put the value. That's wrong. VA is C square. Okay, C, and this is Earth. Okay, here, and same the case C square minus V square Earth. Okay, got it? Okay. So when moving upward, the formula is C square minus V Earth. Okay. When moving downward, the formula is C square Earth downward. When moving away, the formula is yes, by. When moving away. C minus VE, or here C plus VE. Okay. So these are the 4 cases. Okay. So T parallel time for और 1, ठीक है, और 1 ray, ठीक है. Total distance covered. Time is defined velocity divided by time. What is the time formula? What is the formula for time? Velocity is x over t. So t is x divided by v. Okay, x divided by t is h divided v. So total length was L. I have said that. Okay. So time for R1 L, velocity was CVE plus L C minus V. This was a T parallel. Okay. No, so 1 is plus 1. You may write. Okay. Okay. And this will be, if we take L common, this will be C plus VE plus C minus VE divided by C square minus VE square. A square. C plus A square minus B square. Okay. This formula will be this. Okay. And this C will, sorry, plus C. This will be cancelled with this. So this will be a 2L C over C square minus VE square. Okay. Yes. This will be T parallel, means for time covered, for time change. Okay. And what will be the about total time for ray 2? That was the ray 2. Okay. One is A, one is B. Okay. What was the for 2 ray? We say that T perpendicular mean that's what moving perpendicular. Okay. That was equal to velocity, position. The length is same, L divided by C square minus VE square. Yes. Yes. And plus both have the same upward and down. So this is C square minus VE square. Okay. If we take L common, then 1. Okay. When we we don't need to take common. Both will be added. That 2L over C square minus VE square. It may be also right if we take common C, then that will be 1 minus VE over C square. Here we may take common C in this way. That will be 2L okay. So these will be two formulas. Okay, that will be asked in the exam. Okay, to drive. Okay. So here is, you may easily observe that the value, this value is different and this value is different. So that there must be a phase difference must be created. So even when the direction of the earth will be changed, the interference pattern must be a change with passage of time. But Michelson observed that these changes was not observed. So it means the observer will not observe the different velocities. Okay, here it is looking that if we believe on the Galilean transformation, then observer must observe the different velocity, and due to different velocities, different time. This time is different and this time is different. Due to this difference of the time, there must be some interference and diffraction pattern, and there must be a change with passage of time. But it was not happening. That's why it's proved that see the velocity of the speed for both observers. I mean, if it is moving here or here and here, that will be a same. So here we are observing the T is not equal to T parallel. Okay, but observation prove no shifting in pattern, and the C dash mean C, the velocity at rest, the velocity at moving observer, they will be the same. That is the first statement that was observed by the Michelson interferometer and Michelson and this law was and the Einstein used this as saying that the velocity of speed of light will be same for all observers. Okay, for inertial observers, inertial means they moving with the constant speed of light. लिख लें, ठीक है. First postulate speed of light will be same for all inertial frame of so speed of light will be same for all inertial frame means that is moving with the constant speed. Okay, that will be same for in C dash will be equal to C. In CB, you may see that CA is equal to CB. Velocity observed by the frame A and velocity, speed observed by from frame A and speed observed from the observer B. For both, that will be the same. Okay, so that was the. Okay. And second postulate was all laws of physics will remain same for inertial frame. So this is called special. You say it is not Einstein. It is also defined as special theory of relativity. General relativity is different. Okay, that is the actually defined as special theory of relativity. Okay, according to this, CA will be equal to CB. The speed of light will be the same for all observers. Secondly, the law will be not changed. Okay, for today, I think कितना time पड़ा है हमारे पास? Hello. Sorry, when we take the C square is common, the C square will be common. This when we take the C square common, then C square will be cancelled with this C, and that will be 2L over C, 1 over V C square. So this actually this formula was L parallel was 2L over C divided by 1 minus VE over C square. Okay. Now it's okay. Okay. Thanks for correction. Okay. और कोई क्वेश्चन? अब हमने पढ़ना है लॉरेंस ट्रांसफॉर्मेशन. ठीक है, लॉरेंस ट्रांसफॉर्मेशन क्या होती है मैं लिख देता हूँ.